Hi children, welcome to our video, 8th Standard Physics. This is Mrs. Manonmani P, MSc BO, Department of Physics. Now we are going to learn about chapter number 3, Force and Pressure. Yes, the topic is pressure exerted by liquids. Already we have learnt about pressure on last video. What do you mean by pressure? Force per unit area. Learning objectives. First, we have to see about liquid excess pressure on the base of the vessel, dependence of pressure on depth in a liquid, activities based on the dependence of pressure on depth in a liquid. Some of the activities we have to see. And then fourth one, the important law is Pascal's Law. Yes, pressure. You know children, already we have learnt on last video. Now we have to take a hammer and put a nail into a wood. At the time the hammer exerts pressure. Solid exerts pressure. Here liquid also exerts pressure. How liquid exerts pressure we have to see now. All the liquids have same weight. So when we pour liquid into a vessel, the weight of liquid pushes down on the base of the vessel. You know the pressure produced on the bottom of the vessel. We say the liquids exerts pressure on the base of the vessel. Pressure equal to force per unit area. Now we have to discuss about dependence of pressure on depth in a liquid. Yes, depth means what children? Alam. Yes, the pressure in a liquid is not the same at all depth. The pressure exerted by a liquid changes with depth in a liquid. The pressure exerted by a liquid increases with the increasing depth inside the liquid. Whatever that depth will increase, at the time only pressure will increase. The weight of liquid pushes down on the bottom of vessel is more. You know children, see this picture. Here the base of the vessel only high pressure will be there. This is a water. Here low pressure will be there. Yes, now we have to see one activity. Activity 1. Yes, what's activity 1? The pressure of the liquid increases with depth. Depth poga poga every pressure increase agada. And then children, before entering into the activity, we have to know about fluid. What do you mean by fluid? Collective term used for gas and liquids. Already you have studied on lower classes. Gas and liquids together we have to see fluid. Yes, now we have to see about the procedure. Now I have to take a tall vessel, has 4 short and thin tubes and we have to give a name A, B, C, D. The vessel is filled with water and then now I am pouring water through the small pipe. The water from uppermost A is found to travel the shortest distance. Yes, and then next one you know B. And then compared to A, B is moving forward. And then C, compared to B, C is moving forward. And then D, the lowermost tube, D shoots out farthest of all. It goes farthest. How do you observe children? The depth of water near tube A is very small. And the depth ஆழம் வந்து Aல வந்து கொஞ்சம் குறைவா இருக்குது. அதே நம்ம கீழே போக போக Dல it will be the greatest pressure. And now we have to know about as the depth of water in the vessel depth of water will be increases. Pressure exerted by water also increases. Depthக்கு போக போக water உடைய pressure also increase. That's good. Now we have to discuss about activity 2. Liquid exerts equal pressure at the same depth. Now we have to see the activity. Now I have to take a plastic bottle, make 3 holes on equal size. The hole should be exactly the same height also. You have to take a measure by using scale and then you have to take a same height and put the holes. Now I have to pour a water fully. At the time what do you observe? The 3 jets of water can fall at equal distance. Same height la irukumbodhu it will flow equal distance. If the pressure of water at the depth of the holes in the bottle is equal. Now what is the result for this activity? A liquid exerts pressure on walls of its container. Here children, this walls, this container, the liquid excess pressure will be there, and then a liquid excess equal pressure, same depth la irukumbodhu it exerts same equal pressure. Adhe different depth la irukumbodhu the lowest one will be the greatest one. Yes, now we have completed the two activities. Now let's me go to the third activity. Liquid exerts pressure on the bottom of its container. ஒரு கண்டெய்னரோட பாட்டம்ல லிக்விட் வந்து pressure exert பண்ணுது. Now we have to see. Children, this is a device, manometer. It is a device which is used to measure the pressure exerted by liquids. Yes, now we have to see. We have to take 3 transparent pipe, children, and then here now we have to put the bottom. We have to take a balloon and hold that, close that with a balloon, and then here you have to see the 3 conditions will be there. First one, I will not put any water, pour any water, and second one, we have to pour some water inside that transparent pipe. At the time the balloon bulges out, and then more water, I have to put a more water. At the time what my balloon bulges out more. From this, what do you understand, children? We will find that the bulge in the rubber sheet also increases here. So greater the height of water column in the pipe, greater will be the bulge in its rubber sheet bottom. From this we understood a liquid exerts pressure on the bottom of its container, and the pressure exerted by a liquid depends on the height of the liquid column. The pressure exerted by a liquid depends on the height of the liquid column. Yes, the important law in physics, children, that is Pascal's law. The French scientist Blaise Pascal only derived this law. Already we know the SI unit of pressure is Pascal. Now I have to say a last statement now. Any force applied to a confined fluid is transmitted uniformly in all directions throughout the fluid regardless of the shape of the container. The meaning of the confined means that is that water will be fully inside that container. So that is only restricted. Confined means restricted. The pressure in a fluid at rest is the same at all points if they are at the same height. This is a container, children. Here one piston, we will attach the piston through this container, and we have to put the equal holes on this. Now I have to push the piston. At the time that liquid flows in all directions uniformly. So this is a derivation of the Pascal's law. We have to give the force, any force, but here that liquid flows uniformly in all direction. Now I have to give a one force only, but here what all the that holes, it uniformly spread in all direction. This container we have to take and put a piston in it, and we have to keep the piston on the top of the one and fully filled with water. Afterwards we have to put a piston. Now I have to push. At the time it spreads equal directions uniformly in all directions. Yes, this is the principle of Pascal's law is used in hydraulic lift, children. This is a hydraulic lift setup. It is a simple construction. Now here one piston will be there, here one piston will be there, here the car will be there. Now I have to give a force on piston 1. At the time only the force will be F1, and then area is A1. நான் இங்கே ஒரு நார்மலாக ஃபோர்ஸ் கொடுக்குறேன், ஆனால் இங்கே பார்த்தீங்கன்னா ப்ரெஷர் எக்ஸிட் ஆகுது. ஸோ வித் த ஸ்மாலர் ஃபோர்ஸ் அப்ளைட் we can create a larger pressure at platform and bigger tram and objects move up. இப்படி நான் கொடுக்கும்போது அந்த ஆப்ஜெக்ட் வந்து மூவ் ஆகுது. ஸோ ஸ்மால் ப்ரெஷர், நான் ஸ்மாலர் ஃபோர்ஸ் தான் இங்கே அப்ளை பண்ணுறேன், ஆனால் இங்கே ப்ரெஷர் வந்து எக்ஸிஸ்ட் ஆகுது. எஸ். Have you seen children leakage of pipes? Many times we see the jet of water fountain from the leaking joints in the pipeline. In our house also we have to see this. It's due to the very high pressure exerted by water on the sides of the pipes. Already we have learned pressure exerted by the sides of the container, water on the sides of the container. So at the time only fountain water will be formed. Fountain neerootre. So the formation of fountain of water from the leaking of pipes of water supply pipeline tells us that from this what we have observed, water exerts pressure on the walls or on its container. ஒரு கண்டெய்னரில் இருக்கக்கூடிய வால்ஸில் கூட வாட்டர் வந்து ப்ரெஷரை எக்ஸர்ட் பண்ணுது. Yes. Children, have you seen this? This is a dam. As the depth of liquid increases, the sideways pressure on the walls of the vessel gradually increases and it becomes maximum near the bottom of the vessel. You know, children, this is a wall dam setup. The wall of a dam is made thicker at the bottom. Bottom la da thicker irukum, so as to tolerate very high sideways pressure exerted by deep water stored in the reservoir of dam. Yes, children, today we have learned, just we have to recap. Now it's a time for recap. Number one, the pressure of a liquid increases with the depth. ஆழம் அதிகரிக்க pressure will be increase. And then number two, a liquid exerts equal pressure at the same depth. நம்ம சேம் டெப்த்தில் ஈக்குவலாக நம்ம ஹோல்ஸ் போடும்போது liquid exerts equal pressure. Yes, we have learned on the activity. A liquid exerts pressure in all directions. You know, upward direction, downward direction. Liquid exerts pressure in all directions. And then fourth one, Pascal's law. Any force applied to a confined fluid is transmitted uniformly in all directions toward the fluid regardless of the shape of the container. Any force we have to apply to the restricted fluid. At the time it spread, we are giving one force only, but it will spread upon all direction, uniformly in all direction. Thank you, children. I hope you understood this concept today. Thank you.